Good evening, everybody. This is Mr. Lowe with today's lesson, lesson 5.2, mixed numbers. Today, our objective is to review the whole concept, meaning what a whole is in terms of fractions, and to learn about mixed numbers and improper fraction concepts. So, without further ado, here we go. All right, here's our math message. So this is something I want you guys thinking about. We're going to work with pattern blocks tomorrow in class. So I want you to take the following pattern blocks out. You obviously don't have these today. We're going to kind of work with them. It says 2 yellow hexagons, 3 blue rhombuses, and 6 green triangles. If a hexagon is worth 1, what are 5 trapezoids worth? So what I want us to think about as we're going through this is the concept of what a whole is. So if the hexagon is my whole, what are 5 trapezoids? I have a website that we're going to go to. Let me make it a little bit bigger for us. And this is a really cool website. It's on Illumination. It's very easy to find, and I'll give you the objective here in a second. So I believe the question came up saying, okay, well, if I have if a pentagon is my whole, so that is my whole, and we're going to kind of jump back and forth in between two things here. So just give me 1 second. So if the pentagon is my whole, and I can get rid of that, and I can say, well, this equals, whoops, let me go back here, grab my pen, there we go. So if this equals my whole, that's my 1, I want to know what are 5 trapezoids worth. So let's go over here and grab my trapezoids. There's 1, 2, 3, 4, and 5. Now I want to figure out how many 5 trapezoids are worth. Well, I'm sure some of you can probably figure this out pretty easily. Others are kind of looking at it, well, let's turn this around. And if we do that, and I'm going to spin this one around too, just for the fun of it. If we do that, we can grab these two together, and there's one whole. And here comes another whole. And there is what I would say is a half. So when I look at these two and I say, well, what are 5 trapezoids worth? 5 trapezoids, there's 1. Whoops, let's change the marker here. There's 1, 2, 3, 4. 5 trapezoids are equal to 1 whole, 2 wholes, and a half. So that equals 2 and 1/2. 2 and 1/2 now is my improper fraction. So improper fractions have a whole number, which is this one right there, followed with a fraction, which is that number right there. So an improper, or not an improper fraction, a mixed number is a whole number with a fraction next to it. So 1 trapezoid is equal to 1 whole, or 1 pentagon. Wow, I'm getting mixed up here. 1 pentagon is equal to 1 whole, and 5 trapezoids are going to equal 2 wholes. There's 1, there's 2, plus a half. So I get 2 1/2. Alrighty, so let's check and maybe do a couple of more examples here, and I can kind of go through these things and kind of get rid of some stuff for us. 1, 2, 3, 4, 5, 6. Now let's say if I say that 1 triangle now, so let me grab a triangle. There's my triangle. I say that that 1 triangle is going to be equal to, so I got 1 triangle is equal, let's change colors there so you guys can see it. 1 triangle is equal to 1/3 this time. I would like to know what shape is equal to 1 whole. What shape is equal to 1 whole? Well, if I have my triangle, and I know I need 3 triangles, because there's 1/3, there's 2/3, and here is 3/3. So I have to figure out which of these shapes up here are equal to 3 triangles, because 3 triangles now is 1/3, or 3 triangles are 3/3. And we know that from yesterday. There's 1/3, there's 2/3, well, that'd be another third, and another third. And we know that 1/3 plus 1/3 plus 1/3 is 3/3. That's my whole. So now I got to try and figure out how I can take these shapes and make them into another shape, and I think I see the answer. Let me take this triangle here. We're going to take that one and spin it around so it fits in really nicely right here. And that, boys and girls, is my trapezoid. So 3 triangles, or 1/3, if a triangle equals 1/3, 3 of those triangles now are going to be one trapezoid. All right, so that's another good example. Let's try a couple of more here. Let's clear off the screen, and let's get rid of some of our shapes. All right, let's do one more. What if I had a triangle equaling a half this time? So here's my triangle, and that triangle is equal to 1/2. Now I'm trying to figure out what shape is going to be equal to 1 whole. Well, I know that 1/2 plus 1/2 equals 1 whole. And I know that because 1/2 plus 1/2 is 2 halves, which is our 2 halves, which is equal to 1 whole. So I want to grab my triangles because I know I need 2 of them. There's 1, there's 2. And I want to try and put these 2 together so that they equal one of the shapes up in front. I know I'm going to have to probably spin one around, and I think perhaps I see an answer right there. So let's try and combine these 2 together. And that is going to be equal to 1 rhombus. So I have 2 triangles equals 1 rhombus. Okay? Let's try one more example, kind of something that you guys are going to see out of your textbooks. Let me clear my screen here. And let's go ahead and say, well, what if I said to you that one pentagon, or not pentagon, one hexagon is equivalent to 1 whole. So that's what I'm going to say is my rule. That equals 1 whole. I need to know what one of these plus maybe 2 of these are equal to. So I want to know what is this equal to, this whole thing right here. I know this is a whole. I need to figure out what each of these triangles are equal to try and figure out what my mixed number is going to be. And the way I'm going to do that is try and figure out how many triangles fit inside my pentagon, or my hexagon, sorry. And I'm going to try and do that this way, and I think you guys will be able to see what I'm doing. Now I'm going to leave the other ones blank, but you can see I can fit a triangle here, another one here, and another one here. So I have a total of 1, 2, 3, 4, 5, 6 triangles inside my hexagon. That means that each of these triangles are going to be equal to 1/6. So now I know I have 1 whole plus 1/6 plus another 6. That's 1 plus 1/6 plus another 6 is going to equal 1 whole and 2/6. So I get 1 and 2/6 as my mixed number. Now, one thing I didn't really teach you guys, and I'm going to kind of do it right now, is we can take this fraction and convert it into, remember what we called top-heavy fractions. And I call them top-heavy fractions because the numerator, which is the number on the top, is going to be bigger than my denominator, the number on the bottom. The way I do that is the method that I call smile and punch. And by smile and punch, I mean I want you to take that number 6, and I want you to multiply it by the 1, by the whole number. So it's the denominator here times my whole number. There's my smile. And then I punch my numerator by adding it. So it's 6 times 1, which is 6, plus 2, which is 8, which means 8/6 is equivalent to 1 and 2/6. So this becomes my top-heavy fraction, or another name would be an improper fraction. Okay, so we have our mixed number over here. We convert it to an improper fraction by taking my denominator, multiplying it by my whole number, and then adding my numerator. So 6 times 1 is 6, plus 2 is 8, equals 8/6. So far, so good. You're going to do more problems like that when you get to tomorrow's lesson. I can now, I think, get rid of this and go back to my page here. And I want to do one more practice using fractions with rulers. When I use fractions with rulers, we want to go get our ruler here and just kind of show you again so you guys can kind of remember what they look like. And remember, we said that each of these is a 16th. So the distance between here and here is 1/16. And that's 1/16. And that's 1/16. And that's 1/16. Okay, so as we're doing these, this whole distance between 0 and 1 is considered a 16th. Now we break it up into 16 equal pieces. We also see that there are longer lines, like right here, and right here, and right here. Those, if we look at them, each of those are 1/8. So the bigger lines here and here and here and here are eighth marks. And some other fractions can then break that down into fourths or quarters, which would be, let's try and use, I don't know, maybe pink this time, which would be this mark here. That's 1/4. That's 1/4. And that's 1/4. So we have those into fourths. And then the last one we can see, and let's use, I don't know, maybe yellow. Yellow might be hard to see. There's this one right in here. That mark right there is going to be 1/2. So you can see how rulers are broken up first into 16ths. That's the smallest spot. Then the next largest is going to be our 1/8. That's the larger lines. The next larger line, or the next larger measurement, is going to be our fourths, which would be here's a quarter, here's a quarter, here's a quarter, and there's a quarter. And then the last one is our halves, and that's just half the distance between 0 and 1. All right, so tomorrow when you guys come into class, you are going to have pattern blocks on your desk. And your pattern blocks, you're going to start, get your journals, and you're going to turn to, I need to know what page this is, 124. And we're going to work through 124, 125, and 126, as well as 127 too, because that's when we start getting back into our rulers. Okay, and if you remember in the rulers, this is what I was talking about. Here's our 16th marks, there's the 1/8 marks, there's the quarter mark, and that one there is the half mark. All right, hope you guys have a great night and get lots of rest. We'll see you tomorrow.